Hello there. We're still going to be looking at direct versus inverse variations, but now we're going to do them with power rules. If you recall, a power rule is something of this format: y equals k x to the r power. And we're still going to go through all of our tests that we did before. Now, I could just look at this one over here, y equals 10x squared. I know that that fits a power rule. It's going to be this kind of direct variation, but I'm going to test these with a table too, just to show that it still works here when I'm looking at the quotient. So first, I'm going to build that table. All right, there we got the table. Now I'm going to start filling it out. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. I'll do this one simultaneously. Down here we got 0, 1 squared 10, 4, 40, 90, 160. And over here we got negative 1, 1, 0, 4 makes 3, 9 down to 8, and 15. Next, let's look at we think that these are direct, so let's look at the quotient. Now I have to be a little bit careful when looking at these quotients, because obviously if I just do the quotient where I do y divided by x, here I would get 10, here I would get 40 over 2, I get 20, here I get 90 over 3, that would be 30, and that changes each time. So y is not directly proportional to x. I'm going to test something else. I'm testing, as you can see here, y over x squared. And then I'm going to just fill out what those are. Okay, bam, there, got all of those, and then I can down here evaluate 0 over 0 squared. That is going to be undefined. 1 over 1 squared, that is 10. 40 over 2 squared, 40 over 4 is 10. 90 over 9, 10, 10. Those are all 10s. Whereas on this side I got undefined, 0, 3/4, 8/9, 15/16. These numbers are changing all the time. There's no constant proportionality. So this one over here is going to be neither. It is not direct. It is not inverse. Whereas on the left-hand side, we're going to need a sentence. Boom. All right, here's our sentence. Y is directly proportional to x squared. Not x, but x squared, because we had this x squared back up there with a constant of proportionality, 10. All right, I'm not going to make the table for these bottom two. We'll scroll down a little bit and look at how we can get it from the structure. Okay, looking down here, looking at this rule, I see that d is in the denominator, and this one has that nice structure of y equals k x to the r, where it's written down in the denominator, k over x to the r. In fact, I could even rewrite this one as y equals 400 d to the negative second. And if I multiply I times d squared, id, that's always going to be 400. That's my constant of proportionality. And I'll write the sentence reflecting that. Boom, and there's our sentence. I is inversely proportional to d squared. We got to mention that it's d squared with constant of proportionality 400. All right, looking over here, this fits very nicely into that power rule. And if I choose to divide, look at a quotient, I would wind up with v over r cubed equals 4/3 pi, and that's just a number. So this tells me that v is directly proportional to r cubed with constant of proportionality 4/3 pi. I'll bring that sentence right up. Alright, not really sure how to get the pi in the math type there, but we got v is directly proportional to r cubed, because remember we are cubing that over here with our constant of proportionality, abbreviated this time, 4/3 pi. This is the volume of a sphere. The volume of the sphere is directly proportional to the radius cubed with constant of proportionality. If I ever divide those, 4/3 pi. Zooming out. Okay, there's a number of examples of power rules, direct versus inverse, how to test for them using the tables way up here, and then later on how to just get it from the general structure and writing the sentence that will reflect it. Remember down here, for example, to get it as y is inversely proportional to d squared. It's very important, that's a d squared. Constant proportionality 400. Thank you for watching. Character and Scholarship for Life.